All right, next up, let's take a look at the temperature effects on equilibrium. So remember that K is specific at a certain temperature. So if we change the temperature, we change the value of K. And so for this kind of stuff, we can't predict it qualitatively, so we can't tell you exactly how much it's going to shift, but we can do it qualitatively, right? We can tell you whether it's going to shift to the left or right, right? So can predict qualitatively, right? So that's whether it's going to shift towards products or reactants, but not quantitatively. So we can tell you whether it's going to shift to the left or right, but we can't tell you, oh, it's going to, 5 products are going to turn into 3 reactants type of thing. And overall, it's a pretty simple idea. All we need to do is think of heat as a product or as a reactant, depending on the type of reactions. And so we're talking about a reaction absorbing heat or giving off heat. We're talking about whether a reaction is exothermic or endothermic. So for endothermic reactions, let's take a look at those. So we have A in equilibrium with B, and I tell you this is an endothermic reaction. So you want to get pretty good at this. A lot of students kind of mess this up. But if we're thinking about endothermic reactions, the reaction is absorbing heat. If it's absorbing heat, then the heat is a reactant. The heat is a reactant. And so if we increase temperature, we increase the amount of heat added, right? The hotter it is, the more heat we have. And in this case, heat is a reactant, right? Heat is a reactant. We see it on the reactant side. And so if we increase the amount of reactants, our equilibrium will shift towards products. So in this case, A will turn into B or will go towards products because we've added more reactants, because heat is a reactant, because it's an endothermic reaction. And then if we take a look at the other way around, exothermic reaction, think about an exothermic reaction. It's giving off heat. Fire is an exothermic reaction, right? It's releasing heat. If it's releasing heat, that means that it's a product. So we have A to B, and then heat is a product. And so in this case, if we increase the temperature, again, what we're adding here is more heat. However, this time the heat is a product. And so we're going to shift the other way, right? B is going to turn into A. Or we can say that we're going towards reactants. Or we can say we're going to the left. Whichever way, they all say kind of the same thing. And then you want to kind of think about what happens when you do the opposite. What happens when you decrease temperature, right? You're going to have the opposite occurring. So here's just kind of a picture of this, right? You see heat over here. So this is an endothermic reaction. And so we can see here at low heat, low temperatures, right? We're in a kind of an ice bath over here. We're going to favor the reactants, right? Low temperature, because we have low amount of heat. That means we have low reactants. So we're going to shift towards reactants, right? You can see that's a colorless gas. Then we let this water melt. We increase the amount of heat added. So we're adding a reactant. So we're going to favor the products. In this case, the product is a brown color. So you can see the color change occurring.